Sudhamshu, Subhansh, Dhriti, good evening everyone. Keep your videos on. Children, turn on your video, please.
Good
Good
evening,
evening, ma'am. Good evening, Mita.
Good evening, ma'am.
Good evening, Mita. Beta, keep your videos on. We'll wait for just 1 more minute so that everyone else join. Then we will begin with our class. So you all attempted the test. Did you receive your test back? I hope you must have seen what kind of mistakes. I won't say. It was incomplete actually. Dhriti, you scored full marks. And others didn't write some examples, right? So make sure the next time you attempt the test, you learn the examples and everything also. Today also, I will be telling you many more examples related to the topics, the characteristics, so that it is very much clear to all of you. I have to make you all see one video also, very small video. So we'll be discussing about that video also. So first, I would like to know from all of you, is anyone who has any kind of doubt regarding whatever we had studied in the previous class? If anyone has any, then you may ask, and then we are going to move further. Children, I request everyone to keep their videos on during the entire class. I cannot keep on repeating the same thing again and again, right? So I request you all to keep your videos on at all times. Thank you. Sudhanshu and Abhinav also. Okay, so yeah, I was asking if there any child has any doubt in any topics which we have studied till now, you may please ask. Otherwise, we will move further. You may raise your hand if you have any doubts. No? Okay. So yeah. So I'm sorry. In the last class, we started with the topic which was the characteristic of a chemical reaction or a chemical change, in which I had told you about the 6 things. Who can, first of all, summarize what were the 6 features? One feature I'll ask from each one of you, anyone you can say, which tells us that a chemical reaction might have taken place. Yes, let's begin from Aryan. What do you think? Anyone?
Ma'am, change in state.
Abhinav?
Change in temperature.
Aman?
ma'am. Change in state.
Okay, that's already done. Dhriti?
Change in color.
Okay. Shayan?
Transformation of precipitation.
Good. Precipitate. Subhansh?
Change in odor.
Sudhamshu?
Evolution of gas.
Good, but your video is turned off. Zoha?
Change in temperature.
Change in temperature. Very nice. So I think all 6 points you have already covered. But we will be considering a few more examples. On that day, we had just written a very few examples. So I'll tell you a few more examples which involves the chemical reactions. First, we'll begin from the first one, which is the evolution of a gas. In this, I had given you just one example stating that whenever a metal reacts with acid, it leads to the formation of salt and hydrogen gas. So we have many more examples. Characters, or I'll write on a new page so that I can share it. Characteristics of a chemical reaction. So for the first one, which we had discussed, was the evolution of a gas. I'll give you a few equations so that if at all you are supposed to write, you are aware about many of them. So we consider iron. Okay, first and foremost thing before I write this, I would like to know, are you all aware about the symbols? Like what is iron, what is magnesium, what is sodium?
Yes, ma'am.
Is there anyone who is not aware?
Could you repeat, ma'am? What did you say?
Yeah, I am asking, are you all aware that what are the symbols of like iron, copper, magnesium,
Yes, ma'am.
zinc? I was asking this because I don't want that. I'm sorry. I keep on writing and you are like, what is iron? We don't know the symbol. If at all you don't know, you can ask from me, right? Then we have mainly two acids which we will be studying in the entire chemistry of class 10. Basically three, but out of that, mainly two we are going to study. That's one of them is hydrochloric acid. On the reaction of metal with hydrochloric acid, it leads to the formation of iron chloride and hydrogen gas, always represented with an upper arrow. Second example, if I take magnesium, it reacts with HCl again, magnesium chloride and hydrogen gas. Next example, if I take zinc metal and I change the acid to H2SO4, that is sulfuric acid, then it leads to the formation of zinc sulfate and again hydrogen gas. So whenever acids are reacting, always remember that they have hydrogen. So definitely it leads to the evolution of hydrogen gas. This much clear? Then I had also told you about another gas. Who will tell me which gas I had talked about in the last class, apart from hydrogen? Aman, can...
Ma'am, carbon dioxide.
Yes, I told about carbon dioxide gas. So whenever we take a carbonate of metal and again it reacts with any acid, it leads to the formation of salt, which is zinc chloride, plus carbon dioxide gas and water. If I take the example of another carbonate, sodium carbonate, it reacts with maybe sulfuric acid instead of hydrochloric acid. Then it forms sodium sulfate and carbon dioxide gas and water. Fine. Whenever you see a carbonate or you see a bicarbonate, that's a metal carbonate, that's a bicarbonate. So if at all these react with acid, again the same products would be formed, which is sodium sulfate, carbon dioxide gas and water. Siddhishri, good evening.
Good evening.
Better keep your video turned on so that I can see you all and I can understand from your facial expressions if you are able to understand what I'm telling or not. Zoha, not able to understand?
I'm able to.
I'm able to understand. Good. Shayan, understanding dear?
Yes, ma'am.
So this was about the first characteristic which we had studied in that class, right? Then let us, I'm sorry, let us come to the second one. Second one was change in color. Have you ever observed change in color? The reaction which I'm going to write, I would like to know from you people if you have ever seen this reaction in your school. Because I show in my school, so I want to know from you. So I'm so sorry. This is blue in color, copper sulfate. It leads to the formation of green and reddish brown copper. So yeah, anyone has seen this reaction in school? No? I will show you right now.
Ma'am, I saw, ma'am.
You have seen who is saying?
Ma'am,
Aryan.
our teacher did one experiment on it.
So can I show you all right now? Okay, let's see. By the end of this chapter,
Ma'am,
you will
once could you show that, ma'am? Last formula I'm writing.
I will show. We will get back to that page only. Don't you worry about that. So I'll show you the reaction of iron with copper sulfate.
Yes! Simply
Are you
Guitar
able
is
to
the best
hear
app for complete beginners. This was my life
the
before I
video?
got
Or to know more.
Are you able to hear?
The aim of this activity is to observe the changes
Yes,
in the
ma'am.
copper sulfate solution and an iron nail when they react with each other. The materials required in the lab activity are 2 glass tumblers, copper sulfate crystals, sulfuric acid, iron nail, water. Take 2 glass tumblers, copper sulfate crystals, sulfuric acid, and an iron
So
nail.
this reaction also occurs
Fill
without
a glass
sulfuric
tumbler
acid.
up to half with water.
Don't use it then
Add
also.
a teaspoonful of copper sulfate to it. Add a few drops of sulfuric acid to the copper sulfate solution. Observe the changes in the mixture. Take another tumbler and pour some mixture solution in it and keep it aside. Put an iron nail in the first tumbler and keep it undisturbed for half an hour. Observe the changes in the solution. Take out the iron nail and observe the changes on it. We observe that the blue color solution changes to green color in which the nail is present. The color of the nail changes to brown. From the activity, the blue color solution changes to green color because of the formation of a new substance called iron sulfate. The brown color deposited on the iron nail is copper, another new substance.
I hope it was clear. So basically these changes, we are going to study a lot of such kind of reaction in this chapter when we will be studying about the types of reactions. I'll give you a one more very basic example. And I'll show you this also because that's very, very important. I will tell you. So if you take the magnesium ribbon initially and start to burn it, again, it is some gray in color. It leads to the formation of a product which is white in color. Fine. This activity, which I'm going to show you now, the video, is very important. Why? Because it involves some questions which I will be mentioning right away. Fine. So first we will see and then I will mention a few questions related to that. Why I'm showing you this particular video is because this is what actually happens when we do this in the lab. Fine.
VW set is back. फिजिक्स वाला स्कॉलरशिप कम एडमिशन टेस्ट आ चुका है फॉर क्लास 8.
Hello scientific people, how are you today? So today I'm going to show you the demonstration of a chemical reaction, that is burning of magnesium. So here I have a strip of magnesium which is cut from the magnesium ribbon. So this is the magnesium ribbon, and this is Bunsen's burner and a watch glass in which I am going to collect the magnesium oxide, which is white in color. These are the pair of tongs. So when magnesium reacts with oxygen, it requires heat energy, and after initiating this reaction, you will see that the magnesium burns in presence of oxygen to form magnesium oxide, and magnesium burns in oxygen with a brilliant white flame. That is called a dazzling white flame. Very difficult to see that. So let's try the experiment, and here I am going to hold this.
Initially, when we do this experiment, what happens is initially it takes a few minutes for the magnesium ribbon, not minute even, a few seconds it takes for the magnesium ribbon to start burning. As soon as it starts burning, the flame which appears, it is so bright that we are unable to see through the flame. It is so bright. So we always call the burning of magnesium as it burning with the dazzling white flame. Why white? Because the product formed, which is magnesium oxide, is white in color. Dazzling means shining. Now let us see it.
Magnesium ribbon. Actually, we don't require a very big piece of magnesium. It's very handy. You can even break it with your own hands. So I choose to put all other things aside. As you can see that magnesium burns with a dazzling white flame. Now, as the reaction is completed, you can see that this white color thing is being produced. This white color is nothing but magnesium oxide. Even, let's try to break it. This is white color powder.
I hope the reaction is clear to everyone. What happens during the reaction? Now, very important question. First, you should know that the color is white of magnesium oxide, and whenever magnesium burns in oxygen, it always burns with white dazzling flame. This is one thing you should all know. Secondly, the question comes, mark it as a star, an important question it is. The question comes, why, it is an NCERT question also, why we clean magnesium ribbon with the help of sandpaper before burning it. Sandpaper before burning it. So what actually happens is, whenever we leave magnesium oxide in air, automatically it tends to develop a layer of either its oxide or carbonate on its surface. So we need to remove that layer first of all. Then we will get the pure magnesium metal for the reaction to occur. So the answer is so as to remove the layer of oxide or carbonate, the layer of oxide or carbonate formed on its surface. That's all. Clear, everyone? Any doubts, anyone? Okay, chalo. Another last example I like to give you all for the change in color, which is again very basic and you are already aware. I had wrote about this earlier and told that I will be explaining this later. So whenever iron reacts, I'll balance this also. So whenever iron reacts with air and moisture, air means oxygen, moisture means water, it leads to the formation of rust. So again, iron, you are already aware, somewhat gray in color, but the rust which is formed, it is reddish brown in color. I hope the change in color is clear to everyone. Any doubts, anyone? Siddhishri, I asked you to turn on your video, dear. You did not.
Ma'am, I can't turn on my video, ma'am.
you know what to do, you have to post the message.
Ma'am,
Yes, Abhinav.
ma'am, like what do you mean by X into X H2?
Yes, I told you in the first class also that we have the entire topic. Though I will just brief you what exactly this X means. But then we will be discussing about this entire equation later at the end of this chapter. This X actually means that the number of water vapors are not fixed actually. Depending on how many water vapors are there, the value of X can vary from 1, 2, 3, 4, any number. Fine, that's why we write X, because it is not a fixed value. So that's why we write X. Clear now? But we are going to study about corrosion. This is the reaction of corrosion. We will be studying about it later in the chapter. Then third one was the formation of precipitate. Formation of precipitate. I'll just give you two examples for now. First one, which I made you all do in the last class, that was lead nitrate. It reacts with potassium iodide, leading to the formation of potassium iodide. Children, one thing I promise you all, that by the end of this chapter, as I am writing this equation without, like, I don't even need to think, by the end of this chapter, same way is going to happen with you, because every equation has some logic how to write the equations. So when we are going to study about the balancing and all, you will be able to write all of them. Fine? So don't get panicked seeing the equations. You will all be able to learn all of them by the end of this chapter. And I'm sure you will all be equally confident to write the equations. Fine. So this is yellow in color. And for precipitate, we put a down arrow. Actually, there was less space. That's why I've put it up. In the next one, I'll write it more clearly. Next is AgNO3, which is silver nitrate. It reacts with sodium chloride, leading to the formation of AgCl, which is white in color, and lastly NaNO3 is formed along with it. Fine. Then next one, fourth one, change in state. I gave you that example, that is sufficient to write. Change in state, which I had already written. Passing of electricity through water, leading to the formation of hydrogen gas and oxygen gas. Fine. Then let's come to the next one. Who will tell me what was the next one? What is left?
Change in temperature.
Change in temperature. Okay, I will ask you people one very, very simple question. You may raise hand. Whosoever knows the answer can tell me. You are all aware about, first thing is, are you all aware about what photosynthesis is? Yeah.
Yes, ma'am.
Then in photosynthesis, what happens is the plants prepare food by absorbing the sun's heat, right? You're aware about this? So now you people tell me, will this process, means photosynthesis, be exothermic or endothermic?
Ma'am,
Exothermic.
endothermic.
It will be,
Endothermic.
yes, it will be endothermic. So a very basic and very simple example I'll give you of this endothermic, which I told you just now. Photosynthesis. Okay. And next, same exothermic. In this, heat is absorbed in the form of sunlight. Absorbed in the form of sunlight. I'll write the equation also.
Just could you show that the precipitate, ma'am, once?
Sure, I can. And I'll write the equation also here. So what happens is carbon dioxide reacts with water in the presence of sunlight and chlorophyll, leading to the formation of glucose C6H12O6 plus oxygen gas. Clear?
Done, ma'am. Thank you.
Okay, Peter. Then is exothermic. Respiration. Tell me about respiration. Energy is evolved. Energy is formed in what form in respiration? Tell me. Think and tell. I have told you all.
Ma'am, gaseous, no, ma'am. Ma'am, carbon dioxide.
No. Think. Okay, what is respiration first of all? Then I will tell you.
Ma'am, we breathe in and breathe out, no, ma'am.
No. That's not respiration.
Acha.
That is not respiration. Who can tell? Cheyenne. Do you know what is respiration? No?
The process by which plants take in oxygen. The process by which plants take in oxygen and give carbon.
Siddhishri? When you have your biology class? Tomorrow? It's a homework. You have to ask your ma'am. I can teach you now, but I want you to know from your biology teacher only. You have to write it somewhere. What is respiration? You will all come up with the answers on Wednesday. I will see it and then I will move further. Clear, everyone? Leaving it here only. We will discuss about respiration in the next class. Then, the last one, I think it is the change in odor. I had already told no other reaction you have to learn in that. Just one example is sufficient. Not much comes from this particular part. Fine, children. I hope I have covered all the 6 points. This I have already told you all, rotten egg smell. Now we are coming to the next important topic. Rotten egg smell. I'll just see, I wrote all the 5 points, right? Yeah. So let us come to another topic, which also I started in the first class, but we have to continue
Ma'am,
that.
just could you show that formula, ma'am,
Which one?
photosynthesis.
It is being shown, fine. Now I had started telling you something about 2 terms which were balanced and unbalanced chemical equation. I'm sorry. Can I remove, can I move down?
Yes, ma'am. Thank you.
Okay, beta. So now I had, if anyone remembers what I had told, can you tell what was balanced or unbalanced equation? Anyone remembers?
Unbalanced equation is the equation in which there is equal amount of atoms in the reactant side and the product side.
You told this about balanced, right?
Yes.
Very good. In the balanced equation, the number of atoms on the reactant side. I hope you are aware about what reactant is and what product is. Sudhamshu, can you tell me what are reactants? Sudhamshu, you know what are reactants? No? Subhansh, do you know what are reactants?
Reactants are the substance that, when mixed together, form the product.
Basically, the substances which take part in the reaction are reactants, and the substances which are formed after the reaction are the products. Is it clear? Shall I write it again, or are you all clear with this? Beta, you have to revise what is being taught in the class. Otherwise, you will not be able to understand anything. Fine. I very well remember I wrote about reactant and product in the first class itself.
Yes, ma'am.
So reactants are the substances which take part in the reaction. Products are the substances which are formed after the reaction. Clear? Okay, children. Now, what is a balanced equation? It is the equation in which the number of atoms on the reactant side are equal to the number of atoms on the product side. Unbalanced equation is the one in which the number of atoms on the reactant side are not equal to the number of atoms on the product side. An important thing to be mentioned over here is that unbalanced equations are known as equations are also known as skeletal equation, not skeleton, it's skeletal equation. Clear, everyone? Yes or no? That the unbalanced equations are also known as skeletal equation. Now, why do we need to do the balancing? Why are we discussing about these balanced and unbalanced? We can write it any way we want to know. Why do, very important, everyone will listen very carefully because in the next class I'll ask questions first, then only I'll move further. Otherwise, I will not move further. Why do we need to balance the equation? See, children, if I tell you that I am taking half a kg vegetable at home, or your mother says so, fine, because I cannot be there at your place. So your mother tells you that she's taken half a kg of a vegetable, and the product what she has got means after cooking it, it is not 500 grams, it is just 200 grams. Is it possible, children? Sudhanshu and Subhansh, your videos are turned off. I want it on.
Ma'am, 1 second.
Yeah, tell me. What do you all think that if at all your mother is taking 500 grams of vegetable and she tells that only 200 grams has been formed, do you think it is possible? No, of course not.
No, ma'am.
In fact, when she will add some water, some spices and all, those also carry certain mass. Then the mass will increase. Now you may say ki no ma'am, my mother took this much amount of vegetable and she took, for example, 100 ml of water, but the product formed was a little lesser. Then I will agree with you. But why? Because the water which you took when we started to heat our food, that water got converted into steam and it escaped out. That's why the product was a little less than what was taken in the beginning. Fine. Is it clear, everyone? So why do we need to balance the equation? The answer for this is very simple. So as to satisfy the law of conservation of mass. Who can tell me what is law of conservation of mass? Just now you have finished your class 9.
Ma'am, a law of conservation of mass states that the mass of reactant will be equal to the mass of product.
That is how we prove it. But what is the definition of law of conservation of mass? Anyone else?
Ma'am, no matter is created or destroyed during a chemical reaction.
Matter. Not 100% correct. Abhinav, can you?
Ma'am, like just stating it, like, law of conservation of mass, like,
You have to state it only.
but you just said that's my call. Not 100%. Like here, Sudhamsh,
Not 100% correct, but I'm asking what is the exact statement of law of conservation of mass?
Ma'am, could I say?
I'm really not sure.
For a moment, Arun. You know, Abhinav?
I'm kind of not sure, ma'am. I'll just.
Whatever you just tell, even if it's not correct, that's fine. I will tell.
Like number of reactants is equal to number of products.
Okay, fine. That's not incorrect. I'm
Like
not
the
saying
mass of. Mass of reactants
That
into
is
mass of
correct,
products.
but that's what we prove. Like whenever we are asked to show that the particular reaction is following the law of conservation of mass, in that we show it that way. Aaron, you tell me, you were saying you wanted to say.
Ma'am, wait, it is, ma'am, I forgot, ma'am, but there is no change for, I'm sorry, I forgot.
Zoha, would you like to try?
Ma'am, it can neither be created or destroyed in the
Very
process.
good. That's the absolute definition, I would say. Mass can neither. You have just finished class 9th and just forgotten class 9th. Neither be created nor be destroyed during a chemical reaction. So if at all you say that, ma'am, the mass is not matching, for example, during a chemical reaction, and whatever the others are saying, that's also correct. We always show that the mass of reactant is always equal to the mass of the product. So this is the main reason why we need to balance the equation so as to satisfy the law of conservation of mass, which states that mass can neither be created nor be destroyed, which you people agreed with me that if your mother is making the vegetable, then neither the weight of the product, the reactants which she had taken will be very large than the products which are formed, or very less than the products which are formed. You got my point? Am I making sense to you all? Yeah. So why
Yes,
I'm
ma'am.
telling about the vegetable? Because you see that every day in your life. That's a chemical reaction which happens every day in front of you. Fine. So this is the main reason we need to balance the equation so as to satisfy the law of conservation of mass, which states that mass can neither be created nor be destroyed. Clear, everyone? So what we need to, how do we need to know if the equation is balanced or not balanced? Can anyone? Can anyone tell?
Now, what was the question, ma'am?
My question is, by looking at an equation, for example, I write a random equation. I write very easy equation. By looking at this equation, I'm asking, how can you check if it is balanced or not balanced? Aman, can you answer me?
Ma'am, by the number of atoms.
What number of atoms? On which side?
Ma'am, on both. The numbers of atoms should be equal.
Very good, excellent. So basically, how do we check that a given equation is balanced or not? By checking each atom which is there on the reactant side as well as on the product side. Basically, comparing them. By comparing I'll write LHS and RHS. It automatically means LHS means reactant and the RHS means product. So I would like to know the answer from you people only. So Dhamshu, can you tell me what all atoms are present on LHS?
Can I say the balanced equation?
No, just wait, Aaron. So Dhamshu.
I'm Aryan, ma'am.
Oh, sorry. Who answered then? Abhinav. Abhinav,
Yes,
just
ma'am.
wait.
Yeah.
So Dhamshu. So Dhamshu, are you there or you have left the class? I'm not sure. Your video is turned off. You're not unmuting. Siddhishri. 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 Okay. Yeah. Then Dhriti, can you tell me the atoms present on the LHS?
Ma'am, hydrogen and oxygen.
Very good. Then Abhinav, just tell what I'm asking, not the entire equation if you have already done it. Fine. Tell me the atoms on the RHS.
Hydrogen and oxygen.
Very nice. So now, Aman, can you tell me how many hydrogen atoms are there on the LHS?
Ma'am, 2.
Very nice. Shayan, can you tell me about the oxygen atoms on the LHS?
None one.
Very nice. Zoha, what about hydrogen atoms on the product side?
And 2.
Very nice. And Aryan, what about oxygen atoms on the product side?
I'm 2.
Now, Subhansh, looking at this data, can you confirm if this equation is balanced or unbalanced?
It is unbalanced.
Very nice. So this equation is an unbalanced, or what is the other name of this, Aryan?
I'm skeletal.
Very nice. It is a skeletal equation. This equation is a skeletal equation. Now, in the next class, we are going to learn about the balancing of the equation. I hope you are very much clear why we need to balance the equation, what are reactants, what are products, and I have written so many examples for the characteristics. So, homework, I will be messaging though. You have to remember and see all the reactions which are there, which I have told you all today. Fine. And the reason why we need to balance the equation. We will be learning about the balancing in the next class. Fine. And also about the respiration, each one of you need to speak to your biology teacher. Fine.
Thank you, ma'am. Bye, ma'am.
Okay, bye children.
Okay,
Have
ma'am. Bye, ma'am. Thank you.
Thank you.
Thank you.